12. Let's have a look at our homework question from the end of term 1 before we went on lockdown holidays. So here we've got a collision between two cars, our red car and our blue car. Our blue car initially is stationary. It's parked on the side of the road, for example. And our red car is moving at 1.5 meters per second. So not too fast, but there you go. All right, so they're going to bump into each other, and we've got some information already. We know the mass of each car. Our red car has 0.05 kgs of mass, and our blue car has 0.04 kgs of mass. So let's just be aware of these values here. All right, so I'm going to get a little, bit of red. We've got these. I'm not going to write them down as well because they're already given to us. We know our blue car mass is 0.04 and our red car mass is 0.05. So if the velocity of the blue car is 1.2 meters per second after the collision, so they've bumped into each other now, and the blue car is going to start to move, calculate the velocity of the red car afterwards. So the red car has given some of its momentum to the blue car through this collision here, all right? So we have we have an equation that we're going to want to use for this one. So we have our equation P equals mv. P is momentum. Okay. Mass, as you're familiar with, and velocity. Okay. So this is our equation. We're all quite familiar with this equation already, hopefully. So what we want to say, this is a conservation of momentum equation, or question rather. So we can say that Pi, the momentum before the collision, is equal to the momentum after the collision. Okay, so that means the momentums of the two cars before the collision added together is equal to the momentums of the two cars after the collision. All right, so we can expand this here. Pi, I'm going to call this here, it's going to be 1, this will be 2, 3, and 4, okay? So we're going to say P1 plus P2. So these are our two cars' momentums before the collision are equal to our two cars after the collision, P3 plus P4. Hopefully you're all still with us. P3 and P4 are the momentums of the two cars after the collision. So let's expand this further. Let's go and take our P equals mv, this over here, and plonk it into these equations here, okay? So m1v1 plus m2v2 equals m3v3 plus m4v4. Hopefully you're seeing where we're going with this. Now we know most of these variables. There's only one that we don't know. If we look up here at the top, we know velocity 1, we know velocity 2, we know velocity 4, but we don't know velocity 3. That's the one that it's asking us to find. It's asking us to calculate the velocity of the red car after the collision. Okay, so we're looking for this one here. So let's go ahead and substitute in some of the variables that we know. We know mass of our red car is 0.05, so we'll put that in here, 0.05 times our velocity 1.5. I'm going to put this in brackets just so it's a little clearer, plus mass 2, this is our blue car, 0.04 times its initial velocity, 0, okay? Our blue car is not moving before the collision. Do the same on the other side. We know the mass of the red car. The mass doesn't change. That's really nice. 0.05 times V3. Now, V3 is the thing we're looking for, so I'm going to leave that just like that. Okay, plus, now last one, M4, 0.04 times 1.2. Sorry, just had a moment there. Now I'm just going to use my calculator. We're going to work out some values. I'm just going to move this down a little bit so we can see our next line. 0.05 times 1.5. So this value here is going to be 0.075. 0.075 plus 0.04 times 0, which is, of course, 0. This here I'm going to write as 0.05 times V3 in brackets still, plus 0.04 times 1.2, which is 0.048. Okay, so all we've done here is we have just evaluated our brackets to find some values, or in this case, for V3, we've left this as is. Okay, so what I want to do is we want to make now V3 the subject of our equation. Okay, and the way we're going to do that is through some nice rearranging. I'm going to continue to scroll down, follow the maths. What we're going to do is I'm going to be able to subtract 0.48 from both sides. Okay, so I'll squeeze that in there. And what we're going to get is that these are going to cancel on out over here on the right hand side. Okay, so we're going to get 0.075 minus 0.048. We're going to end up on our left hand side with 0.027 equals 0.005 times V3. Cool, we're almost there. V3 is multiplied by 0.05. I just made a little typo there. We'll just go back. Oops. 0.05 times, there we go, V3. And we want to go ahead and leave V3 on that side. So to rearrange our equation here, we have a multiplication symbol. So what's the opposite of multiply? The opposite of multiply is to divide. So we're going to divide both sides by 0.05. Okay. We can hopefully see that these two are going to cancel out on our right hand side, and we're going to be left with, I'm going to swap the sides now, V3 equals 0.027 divide 0.05. 0.54 meters per second. Okay, remember that we need a unit, or it doesn't mean anything. Okay, and if you got that far, that's a nice merit. So that's really good effort there. That's using our conservation of momentum, saying that P before the collision is equal to momentum after collision. All right. Cool. All right. Let's zoom that on out so you can see that in all in one go. Here's now a good time to pause it if you want to look at that equation there. And I'll just note that this is A. All right. Down here, we're going to do B. Our next part. And the question asks us if the duration of the collision was 0.08 seconds. So we know already that T, or change in time, 0.08 seconds. Cool. Calculate the average force of the red car that the red car exerts on the blue car. Okay, so it's asking us to find force. Okay. Very good, very good. All right. So, what we need to do here is think about what equations we need to use. Okay. So, what is our equation? Our equation is F delta T equals change in momentum. Okay, so this is our really nice equation, and hopefully if we remember what this one means is that to change the momentum of an object, you need to exert some amount of force for some amount of time. Okay, so we need to exert force for a period of time to change the momentum. You need to push a car for 10 seconds to make it start moving, all right, this kind of thing. You need to exert some force on a ball for some amount of time to throw it, all right, to give it some momentum, all right. So what we know already delta T, our change in time, our 0.08 seconds, and we need to figure out what's our change in momentum, okay. So the change in momentum is really easy because we're thinking about the force exerted on the blue car. All right. So we know that the blue car's momentum has changed by some amount. So change momentum, any change is given by, we'll say delta P equals our final minus our initial. Okay, this is pretty familiar to us. What's our initial momentum of the car? All right, if we think about, initial momentum of our blue car, it's moving at 0 meters per second, so it has no momentum. All right, and this was seen in our equation here. Our blue car here, P equals 0. Okay, no momentum. But we know our blue car at the end has some amount of momentum. 0.04 times 1.2 gives us 0.048. Okay, this is here. This is our PF. Okay, this is PI for our equation. All right, so what we know is that the change momentum is final minus initial. So we have 0.048 minus our initial, which was 0. So we know our change is just 0.048. And what's our unit? kg, meters per second. Okay, so that's really nice there. Now we're almost there because our equation is very simple to use. So let's go and put some values into this equation over here, shall we? F delta T equals delta P. All right, force times 0.08, this is our time, equals our change of momentum, 0.048. All right, let's go ahead. I'm going to use my calculator. We're going to rearrange this. This is our multiply on our left-hand side, so we need to divide both sides by 0.08. Let's go ahead and do that. And we're going to see that these ones here are going to cancel on out. That's nice to see. We'll get some more room. And so what we're going to do, if our average force equals 0.048 divided by 0.08, my calculator equals 0.6, that's the point, newtons. Okay, average force exerted on the blue car. Nice. Sweet. And that there is also worth a nice, lovely merit. Okay. So that there is our homework. You could have alternatively used the change in momentum of the red car, and you would have got the same answer, but it would have been a more complicated calculation because you do not have one of your momentums being 0. You would have had two non-zero momentums to work with, but you would have got the same answer. Okay, so what I'm going to do, just going to scroll that into view a little bit so you can hopefully see it all. Cool, so that's our homework there. Hopefully that helps. This is a really nice way to lay it out, especially in our change of momentum, is to line up our equal signs right down the middle so that it's really clear what's where in your equation. B, I didn't do quite as tidily, but we can see that my equals are mostly lined up where possible. Okay, so hopefully that helps, and good luck with your holidays. I hope you stay safe and stay well, and I'll see you again in term 2.